Hello everyone, welcome to 1000 Math 7. This is the last video, okay? And in this video today we'll be trying to solve the miscellaneous exercise. But before that, we'll try to solve the miscellaneous examples also. There are three examples, 1, 2 and 3. Okay, and then we will solve the miscellaneous exercise also. But before we start this, I would like to say that please make sure to watch the first 5 lectures that I have done so that you get to know about the theory of what is a set, what are the different ways in which we can represent a set, and how we represent a set of real numbers by the use of intervals, and why we do that exactly, because we cannot list out all the real numbers. It's not possible, okay, because real numbers includes everything, the solid numbers, the fractions, the decimals, the square roots, and everything, okay. Now you also got to know that when you take a set, okay, you can say if it's finite, infinite, or if it's an empty set, right? Empty set means that has no elements in it, okay. And also if you take two sets now, okay, you can compare the two sets and say if they are equal, if they are not equal, okay, and if one is a subset of the other, and if one is a proper subset of the other and the other one is a superset or not. You can say all of those things I've taught you in the theory video. And also you have seen that when you take two sets once again and try to combine them, then combining two sets means a set has what? A set is basically a collection of some elements or some objects. So when you combine two sets, it means that you are combining all the elements of both the sets together and make into one set. That is known as union. Okay, union means to unite. And then intersection of set. Intersection means what? Intersection means to if you take two sets, let's say, okay, and you observe both the sets and find some elements common, so you pick out the common elements from both the sets and make into one set, okay. The common elements from both the sets will be a collection, and that collection is known as the intersection set, okay. And similarly you can take the difference, okay, like if there are two sets, let's say A and B. So when you talk about A minus B, then it means that elements that purely belongs to the set A and not to the set B. And similarly B minus A will be what? Elements that purely belongs to the set B and not to the set A, okay. And also we have seen about the Venn diagrams, okay. Venn diagrams is a way to represent set, right? Venn diagram is also a way to represent set, like we do it in the roster form, we do it in the set builder form, or we do it in the interval form for the case of real numbers, okay. So and yeah, the last one was complement of a set, okay. So complement of a set means what? Whenever a set is given to you and it talks about the complement, make sure to think of a universal set, because when there is a set and you think of the universal set, then the universal set will be bigger. It will have some extra elements. Whatever element is present in this set will be present in the universal set also, but the universal set will have some extra elements. So those extra elements that is not there in this set will be the collection of those extra elements will be the complement set, okay. Now let's go ahead and try to solve the examples first, okay. Let's try to apply all this that we have learned in the lecture videos, and let's try to solve this miscellaneous, because it's a bit challenging, okay. So let's try to solve this. Now the first question here is, show that the set of letters needed to spell cataract. This is a word, cataract, okay. I don't know the exact meaning, it doesn't matter. You can look on the dictionary or make a Google search. What is cataract? It's some kind of a mm, cataract, I think, some kind of a eye. I don't know, leave that, okay. So show that the set of letters needed to spell cataract, okay. Set of letters of this word cataract. Now let the set of letters of this word be X, okay. Let the name of this set be X and the name of the set of letters for this word be Y, let's say, okay. So it says, and the set of letters needed to spell tract are equal, means we need to show that X is equal to Y. So let's try to form the set X first. What is X? X is the set of letters in the word cataract. So in the roster form, how will it look like? First alphabet is C. First letter is C, right? So I'll include C. Then you have A. Okay, I'll include A. Then you have T. I'll include T. Then you have A. I have a already, and if you remember, while representing a set in the roster form, we are not supposed to repeat any element twice, right? So I'll not include a once again, then I'll include R, okay, this R, then A I have already, C, I have a C already, T, I have a T already, okay. So this is the set of letters in the word cataract, and if you try to form the set of letters in the word tract, what will be the set look like, okay? Let's take the first letter, first alphabet or first letter. You can say T, and then R, okay, then A, okay, then C, okay, and then T. I have a T already. So now you have both the sets. The set of letters of the word cataract is this, the set of letters for the word tract is this. Now you need to show that set X is equal to set Y, means both the sets are equal. Now if you go back to the theory of equal sets, when you have two sets, okay, and you need to claim that both the sets are equal, then there are two conditions that needs to be fulfilled. The first condition is that number of elements, okay, number of elements in both the sets, okay, in both the sets should be equal. Both the sets should be equal, okay. And number two is that each and every element should also be equal, okay. Each and every element should be not equal, should be same, or you can say identical, okay. Now let's check for the first condition. So the first condition is that number of elements in both the sets should be same. What is the number of elements in the set X? It is 1 2 3 4. There are 4 elements in this set. There are also 4 elements in this set, 1 2 3 4. So first condition is good to go. The second condition is that each and every element should be same or identical. Now let's check if each and every element of both the sets are same or not. C, there is a C. A, there is a A. T, there is a T. R, there is a R. So all the 4 elements that is present in the set X is same as all the elements present in the set Y. So second condition is also fulfilled, or you can say the other way around. All the elements that is present in the set Y, each and every element is same as the elements present in the set X. So finally, okay, I am not writing each and every line. You also don't need to write, just make sure to write the main lines, okay. Like you can write it in this way: since number of elements in both the sets are same and each and every element in both the sets are same, so set X is equal to set Y. And before then, here you need to write, let X be the set of elements of this word cataract and Y be the set of elements in this way. You need to write it in a proper way in your exam so that your teacher can understand what you are writing, okay. Now the next question is, list all the subsets of the set -1 0 and 1. Okay, this is a set, okay, and we need to list out all the possible subsets of this set. Now let's first give it a name, okay. Let A be equal to what? -1 0 and 1. Let's say this. Now we'll try to list out the subset. So all of you know that null set or phi is a subset of every set, okay. I've taught you about this in the lecture video. So let's say the first subset A1, let's say, okay, A1 is phi, because why? Null set is a subset of every set. Null set means what? Empty set, that is no elements, okay. Now let's start by taking one element at a time. Look at the way how I'm doing, okay. A2 will be what? Taking one element at a time. A3 I'll take 0. A4 I'll take 1. Now check. A2, A3 and A4 are is a set, okay, that has one element each, means these are singleton sets. A set that has just one element is called called as a singleton set, right? So here if you see, A2 is a set that has some elements or just one element, and each of the element that is present in the set A2 is present in the set A. So A2 is a subset of A. This is the basic definition of a subset, okay. Each and every element that is present in the set A3 is present in the set A. So A3 is a subset of A, okay. So in this way, now we'll take two elements at a time, okay. So A5 will be what? Two elements at a time. Let's take -1 and 0 first, okay. A6 will be what? -1 and 1, let's say. A7 will be what? Any other combination, 0 and 1 together I can do, right? 0 and 1 together. So this is all the possible combinations when I take two elements at a time. So A5 is a subset of this set because all the elements, what is the basic definition of a subset? If you have two sets A and B, if all the elements of set A is present in the set B, then A is a subset of B, right? We say in this way. So all the elements of A5 is present in the set A. So A5 is a subset of A, and we are trying to list out all the subsets, okay. Now let's take three elements at a time, okay, because this set has maximum of three elements. So -1 0 and 1. Now if you see here, A8 is a set that has three elements in it, and all the elements that is present in the set A8 is present in the set A. So A8 is also a subset of A, and no more. So I have listed out all the subsets. I've started with the null set, and then I've taken one element at a time, I formed the subset, then I've taken two elements at a time and I formed the subset, and finally I've taken all the three elements together and I formed the subset. Now if you notice, A8 is not a proper subset of A, because A8 is a set that has three elements and all three elements are present in the set A also. Okay, so A8 is a subset of A, but A8 is not a proper subset. Okay, it's not a proper subset. Why? Because to be a proper subset, this set A, okay, this set A should have some extra elements also. It should be bigger. Okay, now here A7 is a proper subset of the set A. Why? Because all the elements that is present in the set A7 is present in the set A, and the set A has something extra also. So that's why A7, A6, A5, A4, A3, A2, these are proper subsets, but this is not a proper subset. Okay, this is just a subset. This is what I've taught you in the lecture video of subset, proper subset and superset. Now, let's derive some conclusion here, okay, that you need to note down. Conclusion that you can note down is number of subsets, okay, is equal to 2 to the power number of elements. Okay, 2 to the power number of elements. Now what is this? Let's check. Here this set was having 3 elements, right? So what is the number of subsets that I have got? See, from A1 till A8 means I've got 8 subsets of this set. So this is according to this rule. Okay, 2 to the power number of elements is what? 3. So 2 to the power 3 is what? 2 into 2 into 2, that is 8. Okay, so I'll have 8 subsets. Now if you have if in your exam, let's say there is a set like this, minus 3, 2, 1 and 0. There are 4 elements in this set and you are asked to list out all the subsets. So how many subsets will you get? You'll get 2 to the power number of elements, that is 4. 16 subsets you will get. Okay, so you can try this. Start with the null set, then take one element at a time, then take two elements at a time, then take three elements at a time, and then finally take all the 4 elements like I did here. Okay, now let's move on to the next question here. Show that if A union B is equal to A intersection B implies A is equal to B. So this is some kind of a proof that we need to do. Okay, so look at it carefully. Here it says A union B means the combination of set A and set B is equal to the intersection of set A and set B. This is the given condition. So if I write the solution of this, given is what? A union B is equal to A intersection B, means they have assumed there are 2 sets A and B. Okay, there is a set A that has some elements in it, like in the roster form. Okay, so there will be some elements separated by a comma. There is a set B which has some elements that is separated by a comma, and we need to show that. Okay, since it says show that if this is happening, then it implies that A and B are equal, means we need to show that set A is equal to set B. Okay, now we can show this when we prove 2 conditions. Whenever there is a whenever you need to show 2 sets equal, always go for or always try to prove 2 conditions. First is A is a subset of B, means what? All the elements that is present in the set A, okay, all the elements that is present in the set A is present in the set B, and the other way around, B is a subset of A. If you prove this, then it means what? All the elements that is present in the set B is also present in the set A, means what? A and B are equal. And this comes from the concept of subset, if you try to recall or if you watch the lecture video. Okay, so if you prove these 2 conditions, okay, A is a subset of B and B is a subset of A, then it means A is equal to B, obviously, right? Only then these 2 will be true. So this is the given condition, okay, and we need to show this. So let's start from this side. Let's try to prove this first. A is a subset of B. So let's say let X be an element, okay, X be an element of set A. Now A may be a set, okay, like this. A is equal to 1, 2, 3. Let's say A is this set. We don't know what are the elements, but just for the sake of an example, I have taken this. So A is 1, 2 and 3. The elements of the set A are 1, 2 and 3. So what I have done is I have assumed each of the element to be X for some time. So that's why I have said let X be an element of the set A. Okay, so here you can see that X can be what? 1, or X can be 2, or X can be 3. So I've just assumed it to be X, kind of a variable. Okay, so let X be an element of the set A. Then what can I say? Then X belongs to A, right? To the left side of belongs to, there is always an element. So X is an element of the set A. This means that. Okay, Now if X is an element of the set A, then what can I say? X will also, or X is also an element of the set A union B, because when A union B is a set that has all the elements of both the set A and the set B together, right? So obviously if this is an element, X is an element of set A, obviously this will also be present in A union B, because A union B is a combination of set A and set B together. Okay, so I can say this. Now what can I say? Then X belongs to A intersection B. Why? Because it's given to us A union B is equal to A intersection B. Okay, in this way. Now this means that then what? X belongs to A and X belongs to B, because union, okay, has to do with or, and intersection, okay, intersection means and, right? I've taught you this in the lecture video. So this intersection means what? And. So I've broken this down into two parts. So what I've done is I've assumed X to be an element of the set A, right? That is, if X belongs to A, then I got to know that what? X also belongs to B, right? Then X also belongs to B, right? That means each and every element that is present, because X can be what? 1, 2 or 3, if you think set A to be this. So each and every element that is present in the set A is also present in the set B. Means what can I say? A is a subset of B, right? This is equation number 1. Now let's try to prove the other way around. We have started from A, we have assumed X to be an element of the set A, and we have proved that A is a subset of B. Now let's try to take an element from the set B. Okay, let Y now. Okay, since I've taken X here, so I'll take Y here. Let Y be an element. Okay, Y be an element of set B. That is, what can I say? Y belongs to B, right? Y is an element of the set B. Now if Y is an element of the set B, then Y will be obviously an element of the set A union B. So I can say Y belongs to A union B also, right? Because the union of A and B will have all the elements of A as well as B. Okay, so now what can I say? Then Y belongs to A intersection B. Since why? Because this is given to us, A union B is equal to A intersection B. Okay, now I can break this down, right? Y belongs to A and Y belongs to B, because this is intersection, and intersection means and. Okay, so I started from this, that is, if Y belongs to the set B, then I got to know that Y also belongs to the set A, right? Then Y also belongs to the set A. Now Y can be any element from the set A, from the set B, right? So Y can be, let's say B is a set that has 1, 2, 3, like this, okay, or 4 or anything. So what can be Y? Y can be 1, Y can be 2, or Y can be 3. So Y belongs to the set B, then Y also belongs to the set A, means these elements are also present in the set A. So what can I say? All the elements that is present in the set B is also present in the set A. I can say B is a subset of A, right? This is equation 2. So from 1 and 2, what can I say? From 1 and 2, since A is a subset of B and B is also a subset of A, so, or therefore, okay, therefore, like this 3 dots, A is equal to B, or set A is equal to set B. This is what can I prove, or what I can prove. Okay, so I hope you got this. The basic idea to show two sets equal is one, prove one of the set to be a subset of the other, that is A is a subset of B, and also show the other way around, that is B is a subset of A. And in order to do this, assume an element X. Okay, let like, you don't know what the set is, right? Or it doesn't matter to us. So whatever element it has, let us assume it to be X for some time, and this we have done while doing the set builder form. In the set builder form, what do? We represent the set, and in this way, in between two curly brackets, we assume each of the element to be X for some time, and we define the common nature of each of the element, right? So this is what we do. Now let's go ahead and try to solve the miscellaneous exercise. Okay, so now look at this carefully. Solution of this. Okay, here it says, decide among the following sets which set are subset of one another. So there are 4 sets, A, B, C and D, and we need to check if A is a subset of B, or A is a subset of C, or A is a subset of D. Similarly, B is a subset of A or not, B is a subset of C or not, C is a subset of D or not, like that. We need to check it. Okay, now if you look at this, set A has been given in the set builder form. See, X such that means A is a set that will have some elements, okay, some elements, and each of the element has been assumed to be X for some time, okay, and it says what, X such that, means each of the element has been assumed to be X, and what is the nature of X? X belongs to real numbers. R means what? Real numbers. And also there is not another condition, X satisfy this equation. Now this is a equation, this is a quadratic equation, right? So let's try to solve this equation. X square minus 8x plus 12 is equal to 0. So this will be 1. X square minus, try to break the middle term, 6x minus 2x plus 12. If you don't know how to solve a quadratic equation, do let me know in the comment section below, okay. Here now take between these two terms, take x common, x minus 6 minus 2, x minus 6 is equal to 0, right? Now this will give you what? X minus 6 common, and then here will be x and here will be minus 2 is equal to 0, right? So product of these two terms is equal to 0, then it means what? Either x minus 6 is equal to 0 or x minus 2 is equal to 0. So if this is 0, then x is equal to 6, or if this is 0, then x is equal to 2. So I've got two values of x, right? And if you see here, x is 2 or x is 6, and both of them are what? Real numbers. 2 and 6 are what? Real numbers. So both the conditions are getting fulfilled. So what is a set A? A is a set that has what? Two elements in it, okay? 2 and 6 in this way, okay? Remove this. So I have converted it into roster form so that I can check the elements, because only when I will be able to check the elements, I will be able to decide if one of the set is a subset of the other or not, okay. Now let's decide. Let's compare the set A with the other ones. Now A is a subset of B. Let's check it. If all the elements of set A is present in the set B, then A will be a subset of B. Let's check. The elements of set A are 2 and 6. The elements of B are 2, 4 and 6, means all the elements of set A is present in the set B. So A is a subset of B. This is right. Now let's compare A with C. All the elements of set A is present in the set C. Yes, 2 and 6 are present. In fact, there is something extra. So A is a subset of C. Now all the elements of set A is present in the set D. No, 2 is not present here. So A is not a subset of D. Okay. So I've done the comparison with A. Now let's compare B with the other three. B is a subset of A? No, because all the elements that is present in the set B is not present in the set A. Okay, B has 2, 4 and 6. A does not have a 4. Okay, so B is not a subset of A. Now compare B with C. All the elements of the set B is present in the set C. Yes, see, 2, 4, 6 is present here. In fact, there is something extra. So B is a subset of C. In fact, a proper subset, because the other one that I'm comparing with has some extra elements also. Okay. Now B is a subset of D? No, because all the elements of B are not present in D. B is not a subset of D. Okay. Now let's compare C. All the elements of C is present in A? No, right? So C is not a subset of A. All the elements of C is also not present in B. So C is not a subset of B. Okay. And C is also not a subset of D. Now let's compare D. All the elements of D is present in A? Yes. D has just one element. This is a singleton set, and all the element that is present in the set D is present in the set A. Okay. A has something extra. So D is a subset of A. In fact, a proper subset of A, because the set A has something extra. A becomes a superset here. Now all the elements of D is present in B? Yes. So D is a subset of B. Okay. And all the elements of D is present in C? Yes. So D is also a subset of C. So this is your answer. This is when you compare A with the other three, this is when you compare B with the other three, and this is when you compare C with the other three, and this is when you compare D with the other three sets. So this is what we were supposed to do. We were supposed to decide among the following sets which are subset of one another. So I've compared everything. Okay. Now let's move on to the next question here. Here it says, in each of the following, determine whether the statement is true and false. If it is true, prove it. If it is false, then give an example. Okay. Let's check here. It says the first one, okay, if X belongs to A, means if X is an element of the set A. Always remember this thing, okay. There are two symbols, epsilon, okay, and there is a symbol of subset. To the left side of epsilon, there will be always element, okay, because an element belongs to, this means what? Belongs to, this means what? Subset, okay. So to the left side of this symbol, there will be always a set. and to the right also there will be always a set, and to the left side of this there will be always an element, and to the right there will be always a set. Okay, so here it says x is an element or x belongs to a. Okay, so there is a set A, some set is there. Okay, and each of the element has been assumed to be x for some time, and it says that x belongs to the set A. Okay, and it says A belongs to B. Now check here, this is a bit tricky. Okay, here it says A belongs to, but you have assumed A to be a set, right? But what did I say? That to the left side of epsilon there will be always a element. So A has been treated as an element. Okay, so if I say A is a set, okay, that has 3 elements, let's say 1, 2 and 3. Okay, assume this. Now B is a set that will have what? 1, 2 and 3. This whole set will be treated as an element. So I'll include the commas and this will be just one element. Okay, and then B may have something extra like 4 and 5, let's say. Okay, so here it says A belongs to B. So A has been treated as an element for some time. So that's why I have included everything inside. So in the set B there are 3 elements. This is one complete element, this is one element, and this is one element. Okay, so don't get confused. Then it says that X belongs to B. Then it says that X belongs to B. Okay, X belongs to B. Now what was X? I have assumed X to be an element of the set A. So X can be either 1 or X can be 2 or X can be 3. But here is 1 an element of the set B? No, right? So I cannot say that X belongs to B because 1, 2, 3 together it's an element, but 1 separately it's not an element, 2 separately it's not an element, and 3 separately it's not an element. Okay, 4 is an element. Okay, but here X was an element of the set A. If you recall, okay, X is an element of the set A. So here in the set B, this whole thing is one element. I cannot say 1 is an element or 2 is an element. Individually they are not elements, but together it's an element. Okay, so this is what? False. I have given you the example here in this way. Okay, so always remember, to the left side of epsilon there will be always an element. Even though it's a set, the set will become an element. Okay, that's why I've included the curly brackets and I've treated it as one element. Okay, now the next one, if A is a subset of B, means what? All the elements that is present in the set A is present in the set B. Okay, and B belongs to C. Okay, here also the set B, since it's to the left of epsilon, it has been treated as an element. Okay, let's say there is a set A. Okay, I'll take the same set 1, 2, 3. Okay, and it says B belongs to C. Okay, A is a subset of B. So if A is this, then B can be what? 1, 2, 3, 4. Okay, all the elements of set A is present in the set B. So A is a subset of B. This is the first condition. Okay, this is good. Now B belongs to C means B has been treated as an element. So what will be the set C? Set C will look like this: 1, 2, 3, 4. The whole B has been treated as an element, so I put it inside as an element. And let's say there are something extra, 5 and 6 also. Okay, then it says that A belongs to C. Now A has been treated as an element. Now check here, A belongs to C, it says. So A has been treated as an element. So C should have been in this way: 1, 2, 3, and then like 5 and 6 like that. Only then, if this is together, 1, 2 and 3 together, then only I can say that A belongs to the set C. But see here, you have one element. This is always treated as just one element. This is one element and this is one element. Okay, so 1, 2 and 3 are there, but here you have 1, 2, 3 and 4. So what? A does not belong to C. Okay, so this is false. But here there is one. If you take another example, okay, let's say there is a set A which is 1, 2 and 3. Okay, and there is a set B which is 1, 2 and 3. Now here also A is a subset of B. Yes, because all the elements of set A is present in the set B, right? And B belongs to C, it says. So let's say C is equal to 1, 2, 3, and there are some extra elements in the set C. Okay, B belongs to C. So I've included the whole thing, the whole set B. I've treated it as an element because it's to the left of a epsilon symbol. So 1, 2, 3, and then 4, 5. Now you can say that A belongs to C because what? See, what is A? A has been treated as an element, right? So this whole thing is present here. You can say this, but in this example you cannot say A does not belong to C. right? So whenever you have some contradiction, or always go by the false. Okay, don't say it to be true, because I can give you this example in which it is true, and in this example it's not true, but all the conditions are getting fulfilled. A is a subset of B. B belongs to C, but A does not belong to C. Here A is a subset of B. B belongs to C, but A also belongs to C. So there is a like contradiction. So always say, whenever it's completely true, then only say true. Okay, if there is even one example that you can think of that makes the whole thing false, then it's false. Okay, now the next one is A is a subset of B. Okay, all the elements that is present in the set A is present in the set B. Okay, let's say A is a set which is 1 2 3. Okay, and there is a set B which is also 1 2 and 3. Okay, let's say this A is a subset of B and B is a subset of C. Okay, so B is a subset of C, means all the elements that is present in the set B is also present in the set C. Let's say 1 2 3 and 4. Okay, so B is also a subset of C. So this too has been given to you. A is a subset of B, so I have done this. A is a subset of B. All elements of A is present in B and all elements of B is present in C, so B is a subset of C. It says then A is a subset of C. Let's check. All the elements of A is present in C. Yes, so A is a subset of C. Okay, you can take any example and check, it will be always true. Okay, so this is true. Now the next one is, if A is a subset of B, not a subset, I'm sorry, okay, cut. So not a subset of B and B is not a subset of C, then A is not a subset of C. Okay, let's try to form this. If A is not a subset of B, let's say there is a set A which is 1 2 3. Okay, 1 2 3, and there is a set B which is, let's say, 3 4 5. So A is not a subset of B. Each and every element of A is not present in B. Say 1 and 2 is not present here, so A is not a subset of B. B is not a subset of C. Okay, let's say C is like this, 5 6 and 7. Okay, B is not a subset of C because 3 and 4 is not present in C, so I cannot say. So A is not a subset of C. 1 2 3 is not present here. Yes, A is not a subset of C, not a subset of C. Okay, so this is true, but I can think of another example. Okay, let's say A is equal to 1 2 3. Okay, and B is A. B is what? A should not be a subset of B, so let's say 3 4 and 5. Okay, this is B, and C is what? Let's say 1 2 3 and let's say 7 and 8. Okay, this is C. Now if you check, A is not a subset of B. Yes, all elements of A is not present in B. And B is not a subset of C. Yes, all elements of B is not present in C. Right, 3 4 and 5 is not present here, but A is a subset of C because all elements of A is present in B. Right, so I can say A is a subset of C. So whenever there is a contradiction, okay, here A was not a subset, here A is a subset by this example. So any example that you think of, if you get a contradiction, okay, always go by false. This is false. Okay, now the next one is, if X belongs to A, means X is an element of the set A and A is not a subset of B. Okay, let's say there is a set A which is 1 2 3. Once again, okay, I'm taking the same thing because you just need to know the basic idea. Okay, if X belongs to A, means X is an element of the set A, means X has been assumed to be, X can be either 1 or 2 or 3. Okay, and A is not a subset of B, means set B is not, A is not a subset, means all elements of A is not present in B. Let's say 3 4 and 5 is there. Okay, so A is not a subset of B. Yes, then X belongs to B, it says. Now what was X? X was an element of the set A. So are all the elements of set A present in B? No, because if X is 1, then 1 is not present here, right? So I cannot say that 1 belongs to B if X is 1. If X is 2, then I can see that 2 is an element of the set A, but 2 is not an element of the set B. So this is X does not belong to B. So this is what? False. This is not true. Okay, so you can take these examples and like write it in your exam if it comes. Okay, take any example that you want and write it according to your own way. The basic thing is you need to understand what is happening here. Okay, now the next one is, if A is a subset of B and X does not belong to B. Okay, A is a subset of B, so it means what? All elements of the set A is present in the set B. So if A is like 1 2 3, then B is like also 1 2 3 will be there for sure, only then A is a subset of B. Okay, and let's say there is some extra element also. Now here it says A is a subset of B. Okay, A is a subset of B, yes, because all elements of A is present in B, and X does not belong to B. So it says that X is an element that does not belong to the set B. Let's say 5. Okay, 5, it does not belong to the set B, right? 5 is not present here. So 5, it does not belong to the set B. Sorry, 5, it does not belong to the set B, right? So let's say X is 5 for some time. So 5 will not, obviously will not be there in the set A, because whatever is present in set A is present in the set B, because A is a subset of B. So X does not belong to A. Yes, this is true. Okay, because if X it is not present in the set B, then it will obviously not be present in the set A. Why? Because A is a subset of B. Each and every element that is present in the set A should be there in the set B. Only then A is a subset of B. So this is true. Okay, now let's move on to the next question. Here it says, let A, B and C be the sets such that A union B is equal to A union C. This has been given. So there are three sets. Okay, A, B and C. We don't know what the sets are. Okay, like A can have a lot of elements like this, like separated by a comma. This is in the roster form. B can be something like this, with a lot of elements in it, and C can be a set with a lot of elements. We don't care about that. Okay, now here it says given. Okay, what is given? A union B is equal to A union C, and also A intersection B is equal to A intersection C. Okay, then we need to show that B is equal to C, means set B and set C are equal. As I've told you before, that whenever you need to show two sets equal, what do? You say you need to show two things. If you need to show that B is equal to C, then show two things. B is a subset of C, and you show C is a subset of B. Now if B is a subset of C, then it means what? According to the definition of subset, all elements of B is present in the set C. And if C is a subset of B, then all elements of the set C, all the elements that is present is also present in the set B. It means basically both the sets are equal, that is B is equal to C. So let's try to prove this condition and this condition. Okay, so to prove the first condition, let's say there is an element, like there are some elements here, right, in the set B. So let's assume each of the element to be X for some time. Okay, so let X be an element. Okay, X be an element of set B, let's say. That is what? X belongs to B, I can say, right? So if X belongs to B, then X will obviously belong to A union B, right? Because A and B, when you combine both of them and find A union B, this will be a set that will have all the elements present in A as well as in B, right? So I can say X will be obviously present in A union B, or X will be an element. Okay, X belongs to, or X is an element of A union B. Now here it says X belongs to, then what can I say? A union C, right? Because why? Since A union B is equal to A union C, right? This is given to us. This is the given part, right? So in place of A union B, I can write A union C. Now X belongs to A, and union means, as I've told you before, it's OR. So I'll write OR, and X belongs to C. So either X belongs to A or X belongs to C. Now I've started with X belongs to B, right? So X belongs to B. So this was what? If X belongs to B, then I got to know that then X belongs to A or X belongs to C. So what can I say? If X belongs to B and X belongs to A, okay, this is the first condition, right? Because there is a OR, so I'll combine this and this first, then I'll combine this and this, okay? And there's now like another condition, that if X belongs to B and X belongs to C, okay, and X belongs to C. Now if X belongs to B and X belongs to A, what can I say? That X belongs to both the set A, like all the elements of set A and set B are same. So what can I say? X belongs to A intersection B, right? Because there is an end. So end means intersection. In this way, you can think. So there is a OR here. Okay, this is the OR condition that I have done. I have combined B with A, then I have combined B with C, and there is a OR here. Now if you see here, X belongs to A intersection B, I have combined this end to be intersection, because end means what? End means intersection. Okay, now X belongs to, what can I write? A intersection C, because why? A intersection B is equal to A intersection C. So just replace it. Now break it down once again. X belongs to A, intersection means and, X belongs to C. Okay. Now if you check here on the other side, okay, let's do this all. Also, if X belongs to B and X belongs to C, means what? If X is an element of the set B, then X is also an element of the set C. Means whatever element is present here is also present here, because X we have assumed to be an element of the set B, right? So what can I say here directly? That all elements that is present in the set B is present in the set C, means B is a subset of C, right? Here also, see, you have started from X belongs to B, right? And you got to know that X belongs to C also, see? So this was if X belongs to B, then what? X belongs to C also. Means what? If all, like you can say in this way itself that B is a subset of C, okay? So this two combined is equation 1. Now let's try to prove the other way around, okay? This one, the second condition, I have shown that B is a subset of C. Okay, now let's try to prove the other condition. Now let's say let Y be an element, okay, Y be an element of set C. Then what can I say? That Y belongs to C, right? So if Y belongs to, Y is an element, or I'm sorry, Y is an element, or Y belongs to the set C, then what can I say? Y will obviously belong to the union of A and C together, because A union C is a set that will have all the elements of A as well as of C. So obviously Y will be present in this set, right? So what can I say next? That Y belongs to A union B. Why? Because A union B is equal to A union C, that has been given to us here, okay? So I'll break this down into two parts. Y belongs to A union means or Y belongs to B. I can say this. Now when I started with if Y belongs to C, I have two conditions now. So let's break it down, okay? There is a or here, and here it is Y belongs to C and Y belongs to A. Okay, this is the first that I've combined, and I'll combine Y belongs to C and Y belongs to B. Now here Y belongs to C and Y belongs to A means what? I can write Y belongs to A intersection C, because there is an and. I'll combine both of them. In place of A intersection C, what can I write? A in intersection B, because this is given to us, so I'll write A intersection B. Okay, now break this down. Y belongs to A and in intersection means and, Y belongs to B. Now if you see here, you started from Y is an element of the set C, and you have proved that Y is an element of the set B also. Now Y has been assumed to be an element here, so Y can be anything that is present in the set C. So what can you say? That each and every element that is present in the set C is also present in the set B. So since Y belongs to C and Y also belongs to B, so C is a what? Subset of B. This is one thing that you can show. Here also Y belongs to C means each and every element that is present in the set C is also present in the set B, means C is a subset of B, right? This I can show. So this two combined is equation 2. So what can I say? From 1 and 2, okay, from 1 and 2, I have shown that B is a subset of C, C is a subset of B. Both the conditions are proved, so B is equal to C. Set B and set C are equal. So this is a bit long, but if you have understood, okay, how I have assumed each of the element to be X, or each of the element to be Y, and how I have proved this will be clear to all of you. Okay, now let's move on to the next question here. Okay, the next question is, show that the following 4 conditions are equivalent. These are the 4 conditions that has been given to you, and you need to show that all of them are equivalent. Now let's look at the first one. The first one says A is a subset of B. Means what? The definition of a subset: all elements that is present in the set A is also present in the set B, and B may have something extra, right? We don't know about that. So here it means, one means what? All elements, okay, all elements of set A is present in B, is present in set B. Like if A is equal to 1, 2, 3, then B will obviously have 1, 2 and 3, and B may have something extra. Okay, so we don't know about that as of now. So the basic idea of A is a subset of B is all the elements of set A is present in set B. Okay, now here A minus B is equal to 5, means this set, what is A minus B? A minus B means what? A minus B is difference of sets, okay, as I've taught you in the lecture video. What does it mean? A minus B is a set, okay. This will have some elements that purely belongs to the set A and not to the set B, okay. Here it says A minus B is 5, means this set has no elements in it, means what? All the elements of, what can I say here? That all elements of A is present in B, present in B. That's why there is what? No such element in the set A that you can say purely belongs to A. Okay, like if A is equal to, let's say, 1 2 3 and B is equal to like 3 4 5, in this case A minus B is equal to what? 1 and 2, because 1 and 2 are the elements that purely belongs to A. It's not present in B. But here this is what? 5, means there is no such element here in the set A that purely belongs to A. So all elements of A is present in B. See the same line, right? All elements of A is present in B. Now check here the next one. A union B is equal to B, it says. So now if you see here, what is A union B? Means all the elements of the set A and set B combined together, right? It says is equal to B. So if A is a set like this 1 2 3, okay, and B is a set like this 1 2 3, obviously, okay, all the elements of A should be present in B. So I have done this. Now either it can be this, or if A is equal to 1 2 3, then B can have something extra 1 2 3 and 4, like this, right? So when you do A union B, what will you get? 1 2 3 itself, which is set B, right? Here also, or you can write set A also, because A is also 1 2 3. But here if you see, A union B will be what? 1 2 3 and 4, which is set B, right? So here it says A union B is equal to equal to B, means only thing that I can say about the set A is that all the elements that is present in set A is present in the set B, okay. So I can say for sure that all elements of set A is present in set B. This I can say, but I cannot say that all the elements of B is also present in A, okay. That is not important for us. Alright, so here it can be anything, but the main idea is that all elements of set A is present in the set B. Only then this is a condition, okay. Now let's look at the next one. A intersection B is equal to A. Now if you look at these two examples only, what is A intersection B? For this one, intersection B will be what? 1 2 3, right? And for this one also, A intersection B will be what? 1 2 and 3, right? Because 4 is not common, and in A intersection we include all the common elements. So this is equal to A, and this is also equal to A. So what can I say here? That all the elements of set A is present in the set B. That's why this is equal to A, okay. So here also, all for this one, all elements, okay, all elements of set A is present in set B, is present in set B. So if you see here, all the four conditions have the same statement, right? All elements of A is present in B. Here A union B is equal to B, so I don't care about if B has something extra, but all elements of A is present in B. Here also all elements of A is present in B. That's why intersection of both the sets is giving us A, okay. So don't get confused in this too. Just keep in mind the basic idea. Whatever B is, all elements of A is present in B. That's why A union B is equal to B, and A intersection B is equal to A, okay. Now if this is clear, let's move on to the next question here, okay. So the next question is, we have done question number 4, okay. The next question is, show that if A is a subset of B, then C minus B is a subset of C minus A. Now see here carefully, okay. Show that if A is a subset of B. Here it is given to us, okay. Given is what? A is a subset of B, means each and every element that is present in the set A, okay. A must be a set like this, and B must be a set like this. So whatever is present in A is also present in B. B may have something extra, or B may not have something extra. It doesn't matter to us as of now. Then you need to show this, that C minus B is a subset of C minus C. Now this is a set, and this is also a set, okay, because C minus B is a set, or it's a collection of the elements that purely belongs to the set C. This is also purely belongs to the set C, not to the set A. This purely belongs to the set C and not to the set B. So if we need to prove this subset, I'll take one element from this set, or let's say there is an element X in this set. Okay, C minus B is a set that will have some elements, right? So let's say each of the element that is present here is assumed to be X. Okay, so let X be an element of set C minus B. Okay, so we will prove this simply. Okay, it's very easy. You'll be able to understand this. So if X is an element that is present in the set C minus B, what can I say? That is, X belongs to C minus B, right? So if I break this down, X belongs to C and X does not belong to B, right? Because C minus B, the basic idea is a set of elements that purely is present in the set C and not in the set B, so it does not belong to. Now X belongs to C and X, now look carefully. Okay, here it says A is a subset of B, right? It's given to you, means all the elements that is present in the set A is also present in the set B. Now if X is an element that is not present in the set B, obviously it will not be present in the set A, because A is a subset of B, right? So X, if it doesn't belong to B, then it does not belong to A also. Why? Since A is a subset of B, all elements of A is present in B. Okay, so if X is not present in B, then X will obviously not be present in the set A for sure. Okay, so when you combine these two, it will become C minus A. So you started from X belongs to C minus B, and you have shown that X belongs to C minus A also. So what can I say? Since X belongs to C minus B, if X belongs to C minus B, then X belongs to C minus A also. Okay, so what, or therefore you can write C minus B is a subset of C minus A. Okay, because X is an element of the set C minus B. X is also an element of the set C minus A. Means what? All the elements that is present in this set is also present in this set. Means this C minus B is a subset of C minus A. Hence proof. Okay. Now the next question is, show that for any sets A and B, there are two sets A and B. Okay, and you need to show that A is equal to this and A union this is equal to this. Okay, now look here carefully. Look at the right hand side. Okay, on the left hand side, this is A, this is a set. Okay, clear. Now this is also a set, right? See, A is equal to A intersection B union A minus B, right? Now A and B has been intersected, so this will be one set. This A minus B is one set, and both of them has been united, so this whole thing is just one set, right? And this is also just one set, and you need to show both of them to be equal. So when you showed B is equal to when you needed to prove B is equal to C, what did you show? That B is a subset of C and C is a subset of B. When you prove these two things, you can say B is equal to C, right? So here also, on the left hand side of equal there is a set, and on the right hand side of equal also there is just one set. So show that A is a subset of A intersection B union A minus B. If you show this and if you show this, A intersection B union A minus B is a subset of A. If you show these two things, then obviously these two sets are what? Equal. Okay, you can prove it in this way, right? So let's get started with this. Let's start from let's try to prove this first. Okay, let's try to prove this first. Let's try to prove this first. Okay, this will be easier for you guys. So let X be an element of this set. Okay, of this one set. I've told you why it is just one set, because after doing all the operations, intersection, then minus, and then union, this will be just one set. Okay, so let X be an element. Okay, let X be an element of this set A intersection B union A minus B. So what can I say? X belongs to this, right? X belongs to A intersection B union A minus B, right? Now let's break it down. X belongs to A intersection B. This union will become what? Or what can I say? X belongs to A minus B, right? So there is a or here. Now X belongs to A intersection B. Now if you try to recall the Venn diagram, okay, this is the intersection part. Now if X is an element that lie in this region, then X will also belong to A, right? for sure. X is a part of A, X is also a part of B, right? So from this, what can I say? X belongs to A and X belongs to B also. Now here there is a or, okay, this or, and here I can say X belongs to A and X does not belong to B, right? Or when you break this down, A minus B is a set of elements that purely belongs to the set A and not the set B. So X does not belong to B, okay, according to the definition of difference of sets. Now see here, you started from this point. See, X is an element of this set, and you have shown that X is also an element of the set A. X is also an element of the set A, right? So what can you say? A intersection B union A minus B is a subset of A, right? This is equation 1. You can show this. Now let's prove the other way around, okay? Let's say, let X be, we'll try to prove this now, okay? Let X be an element, okay? X be an element of set A, okay? Then what can I say? That is X belongs to A, right? So if X belongs to A, then X will obviously, okay, let's prove it in this way, okay? If X belongs to A, what can I say about the set B? Because there are two sets, A and B. So X may belong to B or X may not belong to B, right? These are two conditions. So if X belongs to A and this, if I combine these two conditions for, that is if X belongs to A and X belongs to B, and there will be a or, right? And I'll combine these two conditions, X belongs to A and X does not belong to B, right? This is the two possibilities, that if X is an element of A, then this is A and this is B, let's say. So if X is an element of A, then X will be belonging to B or will not be belonging to B. That is the only possible thing, right? So I've written both the things and I've combined them one by one. Now if X belongs to A and X belongs to B, what can I say? X belongs to A intersection B, and means intersection, okay? And or X belongs to A and X does not belong to B, then I can say X belongs to A minus B, right? So combine these two things, A intersection B union, or means what? Union. I can say X belongs to, right? X belongs to A intersection B, or means union, and then A minus B. So you started from if X belongs to the set A and you have shown that X belongs to this set. So what can I say? A is a subset of A intersection B union A minus B, right? This is what I can say. So comparing 1 and 2, what can you say? Comparing 1 and 2, what can you say? Since this is a subset of this and this is A is also a subset of this, so both of them should be equal, right? So A is equal to A intersection B union A minus B. So keep this thing in mind, okay? Don't get confused by looking at such a big equation. Although it's a big thing, but it's just one set, okay? This is just one set, because A and B are sets. Now A and B has been intersected, so this will be one set. A minus B will be one set, and then they have been united or union. So combine the two sets, you'll just get eventually one set. So basically two sets that you need to prove equal. So show this is a subset of this and this is a subset of this, and then if both of them has been shown like this, then they are what? Equal, okay? Now let's look at the next one here, okay? This one. Let's try to prove this. I think this video has gone too long. There are 7, 8, 9, 10. There are a few more questions, okay? So keep the patience. Now, this I need to prove. Again, this is one set, right? A is a set that has been united with B minus A. So if B minus A is one set, A has been combined, so this will be just one set, right? And this is just one set. A and B has been combined, and we need to show them equal. So first we'll prove this as a subset of this, and then we will prove this as a subset of this. If both the things are proved, then these two sets are what? Equal. Simple, okay? So let's try to do this. Let X be an element of, okay? Let X be an element of this set, okay? This is one set of A union B minus A, right? That is what? X belongs to A union B minus A. I can say, right? Because I have assumed X to be an element of this set. So X belongs to this set, right? So I can break it down. X belongs to A, or union means or X belongs to B minus A, right? Now here it says X belongs to A or X belongs to B minus A. So X belongs to A or. Now see B minus A. Okay, now if you try to recall the Venn diagram, this is the basic Venn diagram, this is a set A and this is a set B. This region is what? This region. Okay, this region is what? A minus B, means elements that purely belongs to A, not to B, because B is this. And similarly this region is what? B minus A, right? B minus A, elements that purely belongs to the set B and not to the set A. And this region is what? A intersection B, right? So here it says X belongs to B minus A. See this region, B minus A. Now this B minus A is what? A subset of what? B. Means if X is an element that is present in this set B minus A, then I can obviously say that X is present in the set B itself, right? So in place of B minus A, I can write X belongs to B, since B is a subset of the set B minus A. Okay, keep this in mind. This is very tricky. See, I'll tell it to you once again. Here it says X belongs to B minus A. What can I say? That X is an element of the set B minus A. B minus A. Okay, this region. Then obviously X is an element of the set B itself, right? Because B minus A is a part of this whole B. So if it's present in B minus A, I can say it's present in the set B itself. That is, B is a subset of B. Sorry, this is, I've written it wrong. B minus A is a subset of the set B. Okay. So since B minus A is a subset of the set B, so I can simply write B. Now if X belongs to A or X belongs to B, I can say what? X belongs to A union B, right? So I've started from this. See, if X belongs to this set, then I've shown that X belongs to this set. Okay. That is, if X belongs to A union B minus A, then X belongs to A union B also. That is, what can I say? Or therefore, A union B minus A is a subset of A union B. This is equation 1. Okay, so I have proved this to be a subset of this one. I hope that you have got this point. Okay, because if X is an element of the set B minus A, then X obviously will be an element of the set B, of this whole B, because B minus A is a part of this B, right? So if it lies in B minus A, then it lies in B itself. Okay, so I can write B here. Now let's try to prove the other way around. Let's assume an element from this set. Okay, so let X be an element. Okay, let X be an element of the set A union B. Okay, that is, what can I say? X belongs to A union B, right? What can I say? X belongs to, when I break it down, X belongs to A or X belongs to B, right? Now X belongs to A or X belongs to B, and you eventually need to get this condition. Okay, so let's say X belongs to A here. Okay, X belongs to A. So if X belongs to A or X belongs to B, I can break this down into two parts. Okay, if X belongs to A, this I've written, and X belongs to B. So if it lies in this B, then it may lie here or it may lie here, right? Or X belongs to A intersection B, it may lie here, or it may lie where? In this region, right? X may belong to B minus A region. Okay, because there are two circles, right? In this way, A and B, this is what? A intersection B, this is what? A minus B, and this is what? B minus A. So I have not concerned, or I am not concerned about this part, because here I don't need a minus B, I need a B minus A. Okay, so I've broken this down into two parts. If X is an element of the set B, okay, of the set B, then obviously it may lie here or it may lie here, means it may lie in the A intersection B region or it may lie in this region. I have broken this into two parts. Now X belongs to A or X belongs to A intersection B. X belongs to A or X belongs to A intersection B. When you combine both of them, it means what? X belongs or X lies in the set A itself, because this region is a part of A. Okay, so this two when combined, this will give you X belongs to A itself. Okay, this means the same thing. Or X belongs to this B minus A. Now when you combine this or, it becomes A union, or means union B minus A. So you started from this. If X is an element of the set A union B, you have shown that X is also an element of this. Means what? A union B is a subset of A union B minus A, right? So this is equation 2. So from 1 and 2, what can you say? That A union B minus A is a, or equal to A union B. This is how you prove it. Okay, now this is the way you need to do only when it is of some more marks, like 10 marks in your exam. This question has been given for 8 marks or 10 marks. then you do this. But if it has less marks, okay, there is another way to solve this question. Let me solve it here itself. Okay, let me write down the questions. A intersection B union A minus B. A is equal to A intersection B union A minus B. And the second question is A union B minus A is equal to A union B. Okay, now look at this carefully. This is the second method, okay, to solve the previous question. Now I'll solve this. Let's solve the first one. Okay, I need to show that A is equal to A intersection B union A minus B. I need to show this. So this is the left hand side of the equal sign and this is the right hand side of the equal sign. So since I cannot do anything with the left hand side, so let's start from the right hand side. Okay, so what is the right hand side? Is equal to A intersection B union A minus B. Now here if you want to apply some property, okay, you see here that A has been combined with B first and then A has been combined with B once again, but there is a minus sign here, so I cannot use the distributive law. What is a distributive law? A union B intersection C is equal to what? A will get first united with B and this intersection will come in between A union C, and there is another law, A intersection B union C will be what? A will first intersect with B, okay, and then this union will come in between A intersection C. So this is distribution of union over intersection, and this is distribution of intersection over union. Okay, so intersection has been distributed 2 times and union has been distributed 2 times. So these are the distributive laws. So if you want to apply this law here, okay, look at this part and this part, something, or this part and this part looks same, but this minus is creating a problem for us, right? So what is A minus B? Okay, can you modify it? Look at this. Okay, look at this diagram. Let me take this page here. Now if you have 2 sets, let's say A and B, okay, this is A and this is B, right? So here it says A minus B. So this is the region, right? This is the region that is A minus B. A minus B, right? So if there is a universal set, okay, what can I write for A instead of A minus B? This is what? What can I write? A intersection B complement, right? So if you see here, this and this will mean the same thing. Why? Let's check. Okay, let's check. A intersection B dash. So if there is a B complement here, okay, B complement means what? All the region outside of B, right? All the region that is this is A and this is B, okay, all the region that is outside of B, right? This is A complement, correct? Now what is A? This is the set A, and intersection of both these things are what? This is A, right? This whole thing is A. So which part is getting intersected? This is the region that is getting intersected, right? Cross lines. There are single lines here, so we'll not focus on this. So this is the region, right? When I do A intersection B dash, so it means A minus B. This region is also known as A minus B. So in place of this, what can I write? A intersection B union A intersection B dash, right? This is what can I write? Okay, now if you see here, see A intersection B union A intersection, like this can be written in this way. These 2 things that has been distributed can be combined. Okay, so A will be outside because A has been broken down, and intersection will be here, and B dash will be combined, B union B dash. Okay, so this is the use of this law. Okay, don't get confused. Now what is B union B dash? B and B complement. Okay, if you look at this set, this is the set B, let's say. Okay, so this is the inside part is B and the outside part is B dash, right? The outside part is B dash, inside part is B. So inside part and the outside part combined will give you the universal set itself, right? So A intersection universal set. Okay, now what is A intersection universal set? If there is a set A like this, okay, there is a set A and there is a universal set. Okay, now A is this, right? And what is U? This is this. So which part is getting crossed out like this? The only region common, that is what? A. So this will be A intersection the universal set, means elements that is common between A and the universal set is what? Elements that is present in the set A itself. And what is A? A is the left hand side, right? So what you have shown, that RHS is equal to LHS, that is, this is equal to this, proved. Okay, in this way also you can do, but there are some properties that is used here, so make sure to keep this in mind. Okay, the distributive law, this is the distributive law. Okay, now let's look at the next one here, how to prove this one. This you cannot play around, so start from the left hand side. Okay, start from the left hand side and eventually we'll get the right hand side. So A union B minus A. Now B minus A, okay, let's try to convert it in, like, let's try to remove this minus so that we can use this law, A union something. Okay, so what is B minus A? Okay, once again, what is B minus A? B minus A is this region, right? This region, this whole region, this is B minus A, right? So what can you write about this region, B minus A? If you think, okay, let's say, let's draw it once again. Okay, let's show it to you. This is A, this is B, and this is B minus A. This part is B minus A, right? So this can be written as B intersection, okay, sorry, B intersection A dash, right? B intersection A dash. Why? Check here. Intersection A dash. So what is A dash? A dash means all the region that is outside of A, right? All the region that is outside of A, in this way, right? This is all the region that is present outside A. Okay, now what is B? B is this whole set B, right? This is whole is B. Now which part is getting crossed out, or intersection is happening? Only in this region, right? Only in this region, okay. So and this region is what? B minus A. So instead of B minus A, what can you write? B intersection A dash. This is what you need to think. Okay, this will come with practice, so do practice a lot. Okay, so A union, what can I write? B intersection A dash, right? Now use this law, A union B intersection C. So instead of a C, you have a dash. So just break it down in this way. So it will become what? A union B first, and then this intersection will come in between, and then A union A dash, right? Now A union B will be as it is, and then intersection. What is A union A dash? A, the inside part, and A dash, the outside part, combined together will give you the universal set, right? So this will be the universal set. Now A union B is a set which has been intersected with the universal set. So what is common between these two sets? This set itself, right? So A union B. Okay, so this is the right hand side. So since LHS is equal to RHS, therefore I can say this is equal to this. So this is the second way in which you can solve this question. Where did the question go? Yeah, this one. Okay, one is the way of assuming X, and one is the way of using the properties of distributive law. Okay, now let's if this is clear, okay, if you have any doubts in this question, do make sure to watch it once again, how I have solved it. You'll be able to understand it. Even after that, if you are not clear, then do let me know in the comment section below. Okay, now let's move on to the next question here. Here it says, using properties of sets, show that this is equal to this and this is equal to this. So I've given you the properties here, right? So let's use the properties. Simple. Let's solve the first one. It says this is equal to this. So I'll not start from the right hand side, because right hand side is just A. Let's start from the left hand side. Okay, left hand side is equal to what? A union A intersection B. So I can break this union over the intersection. So A union A first, and this A intersection will come in between, then A union B will be there, A union B, right? Now what is A union A? Simply A, right? All the elements of set A and the set A combined together will be the elements of set A itself, and then intersection A union B. Okay, now what is A intersection A union B? See, A union B is a set that has all the elements present in A as well as in B, right? All the elements of A as well as B, like separated by commas. Okay, and A is a set that has its own elements. So what is common between these two? The elements present in A, right? So this will be A. Okay, so this is RHS, hence proof. Since LHS equal to RHS, therefore this is equal to this. Okay, now the next one is number 2. let's start from the left hand side once again. Okay, left hand side is equal to A intersection A union B. Now let's break this in intersection down. So this will be A intersection A first, then union will come in between and then A intersection B. Okay, now A intersection A is what? A itself. Okay, A union A is also A intersection A is also A, because what does this mean? A in intersection A. A intersection A means what? The common elements of set A and this set A. So whatever A has will be common to both of them. So it will be set A itself, right? Like if A is what, 1, 2, 3, and I do A intersection A, then I'll try to find the common elements of these two sets, right? 1, 2, 3, like this. So what is common? All of them are common. That is 1, 2, 3, which is what? Set A itself. So this will be A. Now union A intersection B. Now A union A intersection B. If you look at the Venn diagram, okay, this is A, this is B, okay, and this part is A intersection B, right? And this whole thing is A, okay. So when you unite A and this region, this will give you what? A itself. So this is equal to A, okay. This is equal to right hand side. So since LHS equal to RHS, therefore A intersection A union B is equal to A. So here we have just made use of properties and some logic. Okay. In exam you don't need to write or draw this kind of diagrams. Just write that here, since or you don't write, or you don't need to write any anything at all. If you want to write, just write if A since what, A intersection B is a part of A, is a part of the set A. See, intersection B is this region, right? And it's a part of this set A itself. Okay, so this is equal to A. When you unite them, this will be A only. Okay, now let's move on to the next question here. Okay, let's move on to the next question. This is, show that A intersection B is equal to A intersection C need not imply B is equal to C. Let's try to prove this. This is a given condition. Okay, this is given. A intersection B is equal to A intersection C. Now it says need not imply, means it's not necessary that B and C are equal. Now if B and C are equal, how do we prove it? We prove it in this way. B is a subset of C, we first prove this, and C is a subset of B, we prove this. Only then, if these two things are happening, we'll say what? B is equal to C. But here we need to show that B is not equal to C, because it says need not imply. So let's start from this point, from B. Okay, let X be an element. Okay, let X be an element of set B, let's say. So what can I say? X belongs to B, right? Now if X belongs to the set B, what can I say about the set A? Okay, that X will belong to A, then what? X may belong to A or X may not belong to A, right? Why I'm like associating, why I've written B and then I've thought about A, why not about C? See here, A has been like linked with B and A has been linked with C. So when I'm assuming X to be an element of the set B, I'm thinking about A here. Okay, so what can I say? Either it belongs to A or it does not belong to A, this element X. Okay, so if I combine these two things, this and this, then X belongs to B and I can say X belongs to A. Or, right, there is a or, X belongs to B and X does not belong to A, right, does not belong to A. So if X belongs to B and X belongs to A, X belongs to A intersection B, because N means what? Intersection. And this belongs to what? A intersection B is equal to what? A intersection C. So what can I say? A intersection C. Now this, if I break it down once again, then X belongs to A and X belongs to C, right? So I've started from X belongs to B and I've shown that X belongs to C also, means B is a subset of C. Okay, this I have shown. But here if you see, X belongs to B and X does not belong to A. Okay, means what? B is not a subset of A. Okay, or I can say this, X belongs to B and X does not belong to A, means X will not belong to A intersection B, right? Because if you notice here, okay, I'll draw the diagram once again and show you how exactly. Okay, A and B combine, A, B. Okay, now X, it says belongs to the set B. Okay, X can be here or here, only then it will belong to B. But it says X does not belong to A, means X will obviously, if X belongs to B and X does not belong to A at the same time, then X will obviously not lie in this region, because if X is an element in this region, then it will belong to A also, but it does not belong to A. So obviously X will lie in this region, right? So I can say for sure that X will not lie here in the common region. So X does not belong to A intersection B. I can say this, right? So X does not belong to, in place of A intersection B, I can write A intersection C. Okay. From this I can say X does not belong to A and X does not belong to C. So from X belongs to B, I got to know that X does not belong to C. Okay. So B is what? Not a subset of C. So I have shown here B is a subset of C, and here I have shown that B is not a subset of C. So this is what when I started from B. Now let's start from C. Okay, let's try like start from C. Let Y be an element. Okay, Y be an element of set C. Then what can I say? Y belongs to C. Means obviously, what can I say about the set A? Okay, let's try to associate with A that Y may belong to A or Y may not belong to A, right? So these two things, okay, let's try to combine. Y belongs to C and Y belongs to A, or okay, Y belongs to C and Y does not belong to A. Okay, now if I look at this one, Y belongs to C and Y belongs to A, means what? Y belongs to A intersection C. In place of A intersection C, what can I write? A intersection B. Okay, means what? Y belongs to A and Y belongs to B, right? And will come here for this intersection. So I've started from Y belongs to C. I've assumed if Y is an element of C, I've shown that Y is also an element of B, means C is a subset of B. I've shown this. Now here Y belongs to C and Y does not belong to A, means Y will not belong to A intersection C, like I have shown you by using Venn diagrams in this case. Okay, so if Y does not belong to A intersection C, in place of A intersection C, I can write A intersection B, means Y will not belong to A, and will come here. Y will not belong to B also, means what? From Y belongs to C, I have shown that Y does not belong to B, means if Y is present or if Y is an element of the set C, then Y is not an element of the set B. So C is not a subset of B. Okay, so these two things is equation 1 and these two things will be equation 2, and from 1 and 2 I can say, from 1 and 2 what can I say? That it's not necessary that B is equal to C, because if B is equal to C, then this conditions should not have been there. Okay, B should have been a subset of C, C should have been a subset of B, but here I have got a pair in which B is a subset of C and C is a subset of B, but I have also got another contradictory pair in which B is not a subset of C and C is not a subset of B. That's why this is not necessary. Okay, so in this way you prove it. Now let's move on to the next question here. Okay, it's getting too long. I'll make it fast. Let A and B be sets. Now if A intersection X is equal to B intersection X is equal to phi, and A union X is equal to B union X, okay, these two are equal, union of A and X and union B and X, okay, there is for some set X, then show that A is equal to B. Now A, B and X are some sets. Okay, they have given you these conditions, okay, that A union X, when you combine the set A and set X, whatever element it will have, that will be same as when you combine B and the set X. Okay, and when you do intersection of A and X, it will have no elements in it, phi, null set. And when you combine, when you intersect or find the common elements of set B and set X, there will be no such elements, so it will be phi for some set X. Show that A is equal to B. Set A is equal to set B. So in order to show this, what will I show? A is a subset of B, and in the other way I'll show B is a subset of A. If A is a subset of B, all elements of A is present in B. If B is a subset of A, then all elements of B is present in A. So what can I say? A is equal to B. I can prove this. So let's try to prove this first and this. Okay, so let X be an element, X be an element of set A. Okay, that is, what can I say? X belongs to A, right? X belongs to A, then X obviously will belong to A union X, because A union X is a set in which we bring together all the elements of set A and the set X. So obviously if X is an element of this set A, it will be obviously present in the set A union X, right? Now X belongs to B union X. I can say this, right? Because A union X is equal to B union X. This is given to us already. Since given, I'll write, okay, since given, okay. Now what can I write next? That X belongs to B or X belongs to X, right? So I've started from X belongs to A, okay, and I've shown that X belongs to B. Means X belongs to A and X belongs to B. Either this one or, okay, or X belongs to A and X belongs to X, right? Either this is combined with this or this is combined with this. Now if you try to solve this, X belongs to what? A and B. So what can you say? X is an element of the set A and X is also an element of the set B, means A is a subset of B, right? This is equation 1. And X belongs to A and X belongs to X. What can you write? N means what? Intersection X. And X belongs to what? A intersection X is phi. So this is no meaning, okay, or you can simply avoid this because X belongs to phi. Phi is a null set. There is no element in a null set. So this is no meaning. So this is equation 1, okay. Now I have shown this one. A is a subset of B. Let's try to show this. So let's start from B, okay. Let X be an element of set B. That is what? Or Y, let's say, okay, we'll not get confused then. So Y belongs to B, I can say. So Y will obviously belong to B union X because B union X is a set that has all the elements of B and X as well. So if Y is an element of B, then Y will obviously present in this set, okay. So in place of this, I can write A union X because A union X is equal to B union X since it's given, okay. Now I will break this down. Y belongs to A or Y belongs to X, right, in this way. So let's try to write it here on this side, okay. So Y belongs to B and Y belongs to A. This is one possibility. Y belongs to B and Y belongs to A, or Y belongs to B and Y belongs to X. Y belongs to B and Y belongs to X. This is one possibility. So if Y is an element of the set B and Y is also an element of the set A, means what? All elements of B is present in A, means B is a subset of A. This is equation 2. And this is what? I can combine this to B intersection X, and B intersection X is what? Phi. This is no meaning, okay. This is no meaning. So comparing 1 and 2, what can I say? Comparing 1 and 2, B is a subset of A and A is a subset of B. This is by comparing 1 and 2, by comparing equation 1 and equation 2. So what? A is equal to B, hence proved. This is what we needed to prove, okay. So always try to focus on this type of questions because this will enhance your understanding and this will also come in your exams for sure, and this will help you to understand or visualize sets, okay, in terms of Venn diagrams, in terms of roster form and everything. Now let's do the last question. Here it says find set A, B and C such that A in intersection B, okay, A, B and C are 3 sets, okay. There will be some elements, let's say. A intersection B means A and B, when we try to find the common elements and form a set. B intersection C and A intersection C are not empty sets, okay. Means when you do A intersection B, this will have at least one element. It says non-empty, so there should be at least one element. It will not be an empty set, okay. So there will be some common elements between A and B. So let's say A is 1, 2 and 3 and B is, let's say, 3, 4 and 5, okay. And here it says A intersection C is also a non-empty set. So let's say 5, 6 and 7. And A intersection B intersection C is equal to 5, okay. All 3 of them, okay, A intersection B intersection C should be equal to 5. So let's check, is there any common element? 1, 2, 3. 3 is common between these two. 5 is common between these two. But is there any like element that is common between all 3 of them? No. 1 is present in this set only, 2 is present here only in the set A, 3 is present in the set A and set B, not in the set C, 4 is present in the set B only, 5 is present in the, so this is also 5. So these are the 3 sets. Here let's check, find sets A, B and C such that this and this are not empty, okay. A intersection B is what? 3. B in intersection C is what? Common the common element is 5, and A intersection C is also should have some common elements. Okay, let's check. A intersection C, is there anything common? Let's say this is 1, 6 and 7. Okay, instead of this 1, 6 and 7 are the elements, or let's say this is 5. Okay, and this is 5, 6, 1, 5 and 6 are the elements in this way. Now check A intersection C. Yes, there is one common. 1 is the element that is common. B intersection C, there is 5 common. Okay, and intersection B, there is 3 common. So this is kind of a question where you need to form a set, and it should fulfill all these like conditions, that this should be not 5. Okay, it should not be 5, it should not be 5, and it should not be 5, and this should be 5. So I have just formed the sets in this way. 1, 2, 3 are the elements of the set A. B will be what? 3, 4 and 5, and C will be 1, 5 and 6. So that whatever is told in the question, A intersection B, B intersection C, and A intersection C are non-empty sets. See, all of them are non-empty, and this should be an empty set. See, this is empty. Okay, so this is it for today. This was the solution of the whole miscellaneous examples and the exercise. I hope all of you have got to know the way I have solved the questions and how I have used the definition of a subset. Okay, subset, always focus on the definition. Always make sure to clear out your concepts. Okay, and how I have assumed X belongs to A. If I say X belongs to A, then X is an element of A. Like if A is a set, it may have some elements. I don't care about it, how many elements are there, but each of the element has been assumed to be X, like we do in the set builder form. Okay, and I've told you one important thing, that to the left side of epsilon there will be always an element, and to the left side of subset there will be always a set, and to the right side there is a set, to the right side also there is a set. Okay, so whenever if it says A belongs to B, then A is a set, but A will be treated as an element, because to the left side of epsilon there is always an element. Okay, alright, so this is it for today. If you have any doubts or any confusion, do let me know in the comment section below, and I'll be happy to answer all of them. And thank you so much for watching. We'll see you in the next video. Thank you.